Northern Saskatchewan is home to some of the world's most important uranium districts. Along the north shore of Lake Athabasca, the Beaver Lodge Uranium Camp has a long history of uranium discovery and production, beginning in the early 1950s and producing more than 70 million pounds of uranium. This region is defined by large, fault-controlled uranium systems, where repeated structural reactivation created the pathways necessary for uranium-bearing fluids to circulate and deposit mineralization. One of the most important structural features in the Beaver Lodge camp is the Black Bay Shear Zone, a major regional fault system that hosts several past-producing uranium mines. Belmont Resources' Crackingstone Uranium project is strategically positioned along approximately 5 kilometers of this uranium-fertile shear zone, just 6 kilometers from Uranium City, with year-round road access and existing infrastructure nearby. At Crackingstone, uranium mineralization is controlled by a fault-dominated structural framework developed within the Black Bay Shear Zone. Modern airborne uranium radiometric interpretation defines two large uranium domains, north and south, separated by the Crackingstone Fault, a major first-order structure that segments the mineralized system. Rather than isolated targets, Crackingstone represents a large, structurally coherent uranium system. Within these two uranium domains, mineralization is further localized along discrete, fault-controlled corridors, including the Chance Lake, Boom Lake, and Southeastern Fault trends. These structures were repeatedly reactivated, creating fractured ground that acted as pathways for uranium-bearing fluids and locally concentrating uranium mineralization where structural complexity is greatest. Airborne electromagnetic surveys further define conductive trends aligned with major fault zones within the Black Bay Shear Zone. These conductors are interpreted to reflect graphitic horizons, sulfide-bearing structures, or conductive alteration, features commonly associated with uranium systems in the Beaver Lodge district, and they provide additional support for a fertile, structurally controlled uranium system at Crackingstone. Uranium mineralization at Crackingstone has been recognized for decades. In 1958, work at the No. 7 adit returned samples grading up to 15.6% uranium oxide with material shipped to the Laredo mill, averaging approximately 2.3% uranium oxide. Numerous high-grade uranium samples and showings have since been documented across the property, confirming the strength and persistence of the mineralizing system. In 2008, Belmont completed a 20-hole, 3,000-meter diamond drill program over an approximately 1.8-kilometer strike length. Uranium mineralization was intersected in all 20 drill holes, confirming a pervasive, structurally controlled uranium system rather than isolated occurrences. Drilling also intersected hematite alteration, a feature commonly associated with uranium mineralization in the Beaver Lodge camp. These results validated the structural and radiometric targeting approach and provided key vectors for future drilling. With the encouraging results of the 2008 drill program, a second-phase drill program was immediately planned. However, due to a weak uranium market combined with the 2008 financial crisis, the company was unable to attract any funding. Today, the global uranium market has changed dramatically, driven by nuclear energy demand and supply constraints. Belmont has now completed modern data integration, relogging of historical core, and secured a multi-year drilling permit allowing for up to 40 drill holes, valid through November 2028. With permits in hand, a refined geological model, strong structural and geophysical targets defined, and strategic investments for 4 major European and Asian investors, Belmont is positioned to advance Crackingstone toward a high-impact uranium exploration drilling program. The pieces are now in place: data, access, and permits, setting the stage for the next phase of uranium exploration at Crackingstone.